Hello everybody and welcome back to my channel. I'm FlyLore737. Welcome on this Christmas Eve flight, even though the weather is not perfect. We're gonna take this beautiful 737 in Southwest colors from Reno down to Vegas. A pretty short flight anyway, but it will be a very nice opportunity to have a little bit of more in-depth chat about the Autoflight system of the Boeing 737 NG. So without further ado, even though the weather is pretty inclement here, I have also installed Xenviro for this special flight due to the weather that has been in Reno in the last couple of days. Talking about especially the snowfall of yesterday. Still a little bit of snow on the ground as depicted. Anyway, now it's only rainy, so we are not going to de-ice. It was a pity since we don't have to de-ice for this flight, but there will be for sure more opportunities for this operations during winter. Winter has just only started right now, since few days. So without further ado, let's jump into the cockpit and start. In this pre-flight, I will go pretty fast, let's say normal pace, without explaining everything. If you want to have more details about what I'm doing and why am I doing some kind of procedures, please refer to my previous stream on the Boeing 737. Once more, I underline the fact that this video is only for entertainment and not made for any kind of training or other purposes. So without further ado, let's start. Let's try to find everything in the right place. The GPU is connected, so nice. Gonna start a full alignment of the RS. Put some lights on, pretty important in this kind of dark situation. This is, by the way, early morning flight. First morning flight from Reno to Vegas. The plane has not yet been loaded, so we're gonna jump to this in a few seconds. Perfect. We are expecting today a cruise altitude of, let me check on the flight plan, 35,000 feet, and we're gonna land in Vegas, which has an elevation of 2181. So 2200 will do the trick. Perfect. Very nice. Then I'm just proceeding in the flow as I would do in the real aircraft, but of course keep in mind that this simulation is taking into consideration the fact that I'm working alone, so it's a single pilot operation for an aircraft that has been designed for multi-pilot operation. Okay, let's cross-check the weather for Reno. So now it's 0503 knots, 10 miles, light rain, scattered, broken, overcast, 2 degrees. 2956, very low pressure, 2956. And it is set, perfect. And just to have a better overview, let's check also Vegas since now. Gusty wind 198, gusty 19, 10 miles, few, scatter broken 12, 2966. Okay, not too bad in Vegas, but of course we need to keep an eye on the wind. Most probably we're gonna land on runway 19s, 19s left or 19 right. Good, let's go ahead with our flow. I want this, that's good, and now it's time for some lights. Not too much on the background. I don't really like the background, especially in the sim. So, tests. Everything is fine. A little bit of brightness even here. Perfect. Oxygen. Perfect. Sounds good. So what next? Let's jump into the payload of the plane. We are expecting a payload, and let's assume that the operational flight plan matches the load sheet of 30.5. 30.5. And for this trip, we're gonna need 15.6 in fuel. Weather is nice. I don't think there is any delay. Let's assume that there is no delay. So with minimum fuel it will work perfectly. Of course, I will show you the flight plan in a moment, and you will be able to see that there is also an alternator that has been planned. So if I go on Avitab and then to charts, and then I'm gonna grab this flight plan from Reno to Vegas. Here we go. It has been planned with an alternate, which is Ontario, and so we have plenty of fuel. We have 5,500 pounds fuel burn en route. Trip is going to be around an hour, and then we have 44 minutes to go to our alternate to Ontario. Planned at flight level 350, and what else? Cost index is going to be 45. There will be quite a strong crosswind almost in the entire flight, so we will have to take care about that slightly, but not too much, since we are not being delayed because of this crosswind. It's going to be okay anyway. So that's good. And about the charts, let's go and pick up the departure we need from Reno, and from there we've got our airport chart, and then I want the parking gates, and then I want the departure. The expected departure is going to be the Zephyr 6, which is here, and then in case any problem and we need to come back, I also want the approach plate on 16 right for the ILS Zulu. So basically we are parked here at Bravo 7, and then what we're going to do is push back, then via Bravo taxi northbound to holding point Alpha 16 right. The departure is going to be the Zephyr 6 on plate 10-3 Golf, 15th of November 19. So we're going to depart 164 to Zephyr, and then our transition will take us to Pesky. So we're going to go Iposi, then Audley, Pesky, with no other restrictions. If we need to come back for any reason, we just solve the problem, since it's also IFR condition and IMC condition. We're going to go to Zachby using and then Yarku, hold over Yarku, and then come back for an ILS 16 right.
Flight deck fuel is all loaded up and you are good to go.
Good, so the fuel is done. We can start the flight leg and make our passengers sit with the seatbelt fastened, and we dive a little bit into the FMC for our pre-flight. So we are in Reno, and GPS left, route Reno, Vegas 01. Here we go. Flight number is Southwest 1757, and our departure runway 16 right will be the Zephyr 6 with transition passkey, and the arrival, let's assume an approach on runway 19 right with an RNAV approach. So 19 right will be on RNAV. I'm just cross-checking which procedure suits the best. Since there is no ATC, I'm trying to guess what the ATC might give us, since weather is pretty nice. We could have an RNAV RMP Zulu, RNAV Zulu 19 right via Penn with the Cocktail 1 arrival. Yes, Cocktail 1 arrival from basic. Here we go. And then we assume, since there is no ATC, that from Bourbon we're gonna flow to Penn, and that is going to be our straight route for the arrival. Here we go. For the RMP 19 right, RMP Zulu 19 right, which is actually an AR. We're gonna talk a little bit about AR approaches just slightly, because I don't think we're gonna have too much time. So that's good. Then we go into the performance initialization, 125.5. It matches with the zero fuel weight we should have had, and the reserve for this flight, we're gonna have 4.1 for our alternate, 7.5 is gonna be our total reserve. Cost index, we spoke about 45. Cruise altitude 350. Cruise wind 257 at 62, 257 at 62. ISO deviation +4. I'm not sure about this ISO deviation, but we're gonna take it and take it as true. And then we go into our N1 limit page for some takeoff calculation. I'm using an external device, an external software for takeoff calculations for the Zibo 737, but the results will be matching exactly what I will be setting up on the into the FMC as soon as we have the results out of the calculation. The weather, of course, reports runway wet with a temperature of +2 degrees. Let's assume that the runway is not contaminated, but anyway, for a departure in these conditions, out of runway 16 right, we are going to use a takeoff 2, no TAS, flaps 5, trim is going to be 535. I'm going to add slightly more as usual, as I explained in the previous video, in the previous stream. 1500 thrust reduction, acceleration 3000, and then the runway wind is almost neglectable, 0503. Runway, of course, is wet, and speeds we do have was 132, 139 and 144. Good. In case of any problems, we are going to follow this little route that takes us inbound two fixes. ZACB first, and the second one is called Usain. Perfect. And the third one is going to be Yarku. Okay. This is maybe an option for the 737 NG, because actually, as far as I know, there are two versions of the software into the FMC. The one kind of software allows 2 pages in the fix page, where you can put maximum of 2 fixes at the same time, and another version of software allows 6 pages. But I've never seen a software version where you can manually add a fix, and then you've got a extra page where you can put another one. So I don't know if it's a variable of the Zibo, or if it's a software that I don't know at all. I've never seen something like that anyway. But yeah, let's go back to our N1 and takeoff page. So 144 is the V2, so we go 144 here. Perfect. And we are nice and good to go. This, of course, will be an LNAV VNAV departure, since we don't expect any vectors out of the runway. Initial top altitude is going to be flight level 190, like that. So what we do have, 164 here, 164, 190, 164 here, LNAV, VNAV, we can already arm in white on the FMA, and that's it. From the Navigate side, I just want the VOR 10.9 on standby frequencies where it is already. Let's assume that the ATC gave us a transponder code 3112, and we are running on ATC2 and altitude reporting number 2, since the first officer is the pilot flying. So far, so good. At this point, we can actually start the APU. Let's start the APU, yeah, for sure. Good. And read the pre-flight checklist to the line. So pins and covers are removed, oxygen tested 100%, nav transfer and display switches normal auto. Window heat is on, pressurization mode selector auto, flight instrument track 342, altimeter 2956, reading 4430. Parking brake is set. And engine start levers cut off, taxi and takeoff briefing is completed. I'm setting up the trim. We're gonna go around 6.5. I guess it's gonna be okay for our takeoff today. Perfect. And we are almost hitting our time of departure, because we are scheduled at 6:45. So let's remove the loaders, and the APU should be ready. Yes, it is. APU is going on bus. Timing, and on the overhead we're gonna check the APU output is correct, and it is on bus, so we can just remove the ground power. So disconnect the GPU, close the doors. We can also remove the jet bridge and call for pushback. Like that.
Great news, Captain. Your tow's coming.
So nice. Tow truck is coming. Hitting 1 minute, almost 1 minute on the APU warm up. That's good. And all doors are closed, and let's assume that from the ground crew, they told us that the pin is inserted, so we can do our flow. 1 minute has elapsed for sure. So nice. We have been cleared to push.
Looks like the doors and hatches are closed. We're ready to connect.
So they are connecting.
Flight attendants prepare for departure. Cross-check and all call. Thank you.
And from the outside, they have removed the chocks, and they are proceeding to engage the nose wheel. That's good. Time is up for our departure, so we are really good to go and perfectly on time.
Welcome aboard, Captain. Toes connected. 5 past 10 inserted. Go and kill the parking brake when you're ready to go.
Good. So we can read. I've been a little bit behind. The pre-flight checklist below the line. So fuel. We have 15,600 with 4 pumps on. Passenger sign is set. Auto brake RTO. CDU pre-flight and ACARS completed. Takeoff speeds V1132, VR139, V2144, MCP V2144, heading 164, altitude level 190, and pre-flight checklist completed to below the line. Then before start, the flight deck door closed and locked, the doors and windows closed and locked, anti-collision light is on. Transponder, we go in altitude reporting off, and rudder and aileron trim is free and 0. Checklist complete. Timing and releasing the brakes. Perfect.
Here comes the pushback. Light 'em up.
Perfect. Starting pushback is going to be number 2 and number 1 in sequence. No delay. Within 3 minutes from the target of block time, so no delay at all. Good. Oh, a little bit of problems with Xenviro sometimes in some view, but okay, let's start the engines. Starting 2 and 1 in sequence. Number 2, we have hydraulic pressure, and we monitor the startup. Starter cut out. Engine number 2 is stable. Start engine number 1. Starting number 1. And of course, Merry Christmas. So both engines are stable, and as per my company SOP, we have to wait until the ground crew has completely disconnected and have gone away from the aircraft before starting the flow. Anyway, just for saving some time purpose, I'm just anticipating the flow.
And we're disconnected. Signal and pin on the left. Take it easy and have a safe flight.
Perfect. Thank you so much. Have a very good day, you too. Okay, they are disconnecting. Flap 5. Waiting for their signal. Here we go. Pin seen. Flight control checks. Full up, center, full down, center, left, center, right, center, rudder, full left, center, and full right. Before taxi checklist, generators on, probeat is on, NTIs, we have engine NTIs on, air conditioning and pressurization packs auto, isolation valve auto, engine start switches continues, recall checked, engine start levers idle detent, flight controls checked, ground equipment clear, flaps. 5 plane, 5 green lights, and APU is off before taxi checklist is completed. Very nice, clear right, clear left, let's turn off the dome light, it's very annoying, and have some wipers. Lights on, clear right, clear left, and off we go. Parking brake released. So we have been cleared to taxi straight, then join left on Bravo to holding point Alpha, runway 16 right. Let's see if I can grab it from here. No, unfortunately not. I need to go on to the EFB of the 737 to change. This is, I think, a limitation or a bad interaction. I'm not sure. Maybe I don't know exactly how to do it, but it looks like that there is a bad interaction between the 737 EFB and Avitab in some kind of situations. Good. So let's go back here, and then airport, and then we pick up the chart. Yes. Now I should be able to show you here. Perfect. Yes. Joining the Bravo taxiway all the way up to holding point Alpha, runway 16 right. And from there, the departure is gonna be the Zephyr 6, pretty short, and then the transition will lead us to Pesquet. Good. For those of you who are wondering how the settings of my Xenviro are, is default. This is everything at default, and it's running on AMD 5950X with 64 gigs of RAM, and the graphic card is the RTX 3090. Almost there at the holding point. Meanwhile, let's assume that we have received the cabin ready signal from our cabin crews and the clearance from the ATC to line up and take off. So in this case, the departure clearance would sound most probably something like Southwest 1757, runway 16 right. It's going to be an RNAV to Zephyr, wind 050 at 3, clear for takeoff. So clear for takeoff 16 right, RNAV to Zephyr, Southwest 1557. So putting some lights on, starting from here and there.
Okay, the cabin is secured. Have a good flight.
Thank you. Have a good flight, you too. of course I'm running on OpenGL. That's why sometimes there is a little bit of lags in the simulation. Good. Now I need the transponder. And before takeoff checklist. Before takeoff checklist. The flaps. 5 plane, 5 green lights. Stop trim is set. 6.2 units. Cabin call is given before takeoff checklist is completed. Lights are on. We've got the engine NTIs. Timing. And ready for rock and roll. Stable. Set takeoff thrust. Takeoff thrust set. Checked.
E1. Rotate. Positive rate.
Gear up. Very nice, nicely. And it's important in these conditions to look at the instrument, not to look outside. VNAV speed.
1000.
Command B. Can turn off the wipers. N1. We are cleared to 190, so we can delete the reduced climb thrust. Full climb thrust is set, so we can climb more rapidly. Acceleration. That's good. Positive speed trend. Flap 1. Flaps up. Flaps up, no lights. That's good. Engine start switcher stays in continuous. That's good. And let's assume that the ATC now is going to clear us all the way up to flight level 350 cruise. So level 350 is set and checked 1, 2, and 3 times. Cloud layer. Turning left on our transition, first to oddly and then to pesky. Nice climb out through the clouds. Let's have a look from the outside. Watch your ears. Here we go. Passing 10,000, that's good. External lights off. Wing light off. I think also it should be okay as a turbulent situation, so seatbelt signs to auto, out of the clouds, engine anti-ice off, engine start switches to off, after takeoff checklist. Engine bleeds on, packs auto, landing gear up and off, flaps up, no lights, and standing by for altimeters. Nice morning view. Nice morning view out of the clouds from Reno to Vegas on this Christmas Eve. We can clean up the fixed page now and go on fixed page, delete, delete, and delete. That's good. Even though we have a optimum cruise level of 39035, sounds more reasonable since it's not quite a long flight. I think it's gonna be perfect. So far so good. Our cruise segment most probably is gonna be something like 100 miles, not more, I think. Top of climb in about 80 and top of descent in about 200, roughly. I'm wondering when this water coming from the wiper will be gone. It's a very nice effect indeed, but I think now it should be gone, or it's going right now. I think it's like becoming lesser and less, so probably, yeah, it's fading. And there is a beautiful sunrise over Nevada. Very nice. So we were talking about when I did the introduction to this stream, I was talking about that the focus of this stream would have been the Autoflight System, the autopilot. We are going to go pretty much in depth talking about the Autoflight System of the Boeing 737 NG. Now I'm just passing the transition, so let's do standard, set and cross check, so the after takeoff checklist is completed. So nice. And well, what to say? There are two elements, key elements in the 737 Autoflight System that are the MCP, which is this one, the mode control panel. So it's the interface between pilots and the aircraft itself to tell the aircraft how to manage the various flight phases. And then there is the auto throttle system, which is armed by this switch, and it's incorporated in the throttle quadrant. Then there are of course the autopilot actuators that are used to move ailerons, elevators, rudder in some cases, and then the trim system itself, of course, and then the two flight controls computer, the two FCCs, FCC-A and the FCC-B. The flight control computers are like the background or the backbone of the autopilot system. So what to say about that? The flight controls computer calculate the pitch and roll for the autoflight system. Of course, the auto throttle is a function coming from the flight control computer A only. So it's one channel of auto throttle. We don't have two channels auto throttle like the 747 or the 777, for example, or the Dreamliner. They have dual channel auto throttle. We don't. We have just one. And then, of course, as I told you before, there are two flight controls computer, FCC-A and FCC-B. These are sending control commands to the pitch and the roll hydraulic autopilot actuators that are operating via the two hydraulic systems. So we do have on board the system A and the system B. These are the pumps of the system A. These are the pumps of the system B. They have been cross-connected, engine 1, ELEC 2, ELEC 1, engine 2, because they are served by two pumps each. One connected to the engine that is running when the engine is running, and the other one is electrical. So it's independent of the engine motion. But anyway, of course, these two systems are used to power the actuators with hydraulic. And then, of course, we have the flight control computer that receives pitch and heading data from the IRS. Of course, IRS comes up here, all the way up here, because the IRS senses the motion of the aircraft, the accelerations going on. And of course, IRS left is coupled to flight control computer A, and IRS right is coupled to flight control computer A, because they are offside connected. Then each flight control computer has two 16-bit CPUs which are calculating the commands. They are cross-checking to prevent failure or of pitch and command roll, of pitch and roll commands at the same times. So of course, if they sense something wrong in the system, they disengage the autopilot immediately. So instead of giving the autopilot the chance to do something wrong or not wanted, they are just cutting the autopilot system and let the pilots decide and fly manually the aircraft without any delay. And of course, the speed trim, Mach trim and altitude alerting system that we will hear soon when we are coming around the top of climb are also part of the Autoflight system. We have the stub trim switches here, and the speed trim, of course, is part of the system. Speed trim at low speed. We have Mach trim at high speed, and of course the altitude alert system. If there is any failure of these systems, we have alerts on the overhead panel, and we have alerts here in the real aircraft. We should be able to lit these lights, but anyway, you see speed trim fail here and Mach trim fail here. Okay, so we have annunciation of problems in these systems up here, and of course there would be also the flight control lit on the master caution as well. That's it. Then we have the actuators. There are 4 actuators in total. Each flight controls computer controls one aileron and one elevator actuator, so they are cross-connected. FCC-A, hydraulic system A, FCC-B, hydraulic system B. And each actuator is mechanically linked to the flight controls. So if there is a jam in the actuator, the control column will become, of course, unmovable, impossible to move, and it has been calculated and proved that a force of about 100 pounds, so around 45 to 50 kilograms, is going to be enough to overcome any jamming situation of the flight controls. Then we have our MCP, mode control panel. We can zoom in a little bit better here and trying not to have this glare. And how it's made? It's made, of course, it is a copy of what was available in the Boeing 737 Classic 99% of the commands available here are also available in the Classics and are available in the 737 MAX series as well. So we have the course connected to the captain side, flight director switch, auto throttle switch, IAS, Mac, window and knob, heading, window and knob, with the possibility to modify the bank angle when we are in heading select mode. We have altitude, window and knob, vertical speed, window and wheel. Then we have the autopilot engage system. Command mode A and B. We have two different autopilots, two channels in command mode, and control wheel steering mode. Control wheel steering mode, it's not widely used. I think I've never used it in my life, or maybe once in the real aircraft. And it's a mode where the aircraft stays in the way you put it. So, for example, let's assume that we are climbing at 1500 feet per minute at 280 knots with this thrust setting. I use the control wheel steering, and the aircraft will keep this data, this rate of climb, this speed, as long as I don't move the control column. When I move the control column, the aircraft is picking up what I am doing, what input I am doing in the control column. Instead, in the command mode, that is the most widely used mode, I engage the command mode. If I move the control column, or for example I hit the trim buttons, the trim switches, the autopilot is disconnecting, is kicking off. So these are the two differences between the command mode and the control wheel steering mode. When it is control wheel steering mode suggested, Boeing Flight Crew Training Manual suggested to use the control wheel steering when there is severe turbulence. Because the system is not so tough on the controls, then control wheel steering is much more appreciated when there are strong variation in height, shear, heading of the aircraft. Then more in depth, what about the flight directors? Flight directors, we have left flight directors, right flight directors. This is the altitude alerting system, by the way. It's visual and oral. I don't think you could hear the oral system. It's like a chime, but it's done 900 feet before the preset altitude on the MCP. And then why this is dark and this is lit? This light is connected to the flight director. This means master. So now the pilot flying, monitoring the leveling off, FMC speed, VNAV path, that's correct. Throttles are coming back, will be coming back soon. Should be coming back. Yeah, here we go, coming back, that's good. So what can I do now is to go on to N1 limit, select climb for safety reasons. That's good. So this is the master, and master is always pilot flying side. So in this flight, first officer is flying, so he is the master. When you press the toga button during takeoff roll, both flight director must be on, and you will see the master lights coming on both sides. And then when the takeoff mode automatically disengages, the master side stays only on the pilot flying side. How to decide who is the master? The flight director that is turned on first is the master. So if in my cockpit preparation I am turning on the first officer flight director first, then this is going to be the master. If I'm turning on the captain first, then he is going to be the master. This is the difference. Auto throttle system is armed when we line up, as per company SOPs. Some other SOPs says that you can already arm the auto throttle at the gate. before the engine startup. The problem is that if you have the auto throttle engaged and you hit by mistake the toga button on the throttle, then the engines are spooling up to the takeoff thrust. So I am really fond about the SOPs that are saying not to arm the auto throttle until you are on the runway actually. Then what else? N1, what does it do? It just commands the engine to go to the green arrow, to the green pointer. It's used, for example, during initial climb. Speed, I can manage the speed manually with the knob and checking the speed in the window. Changeover button, I can change between IS and Mach mode in the window. Level change is used during descent. It will retard the throttle to idle and descend with given rate or own rate for a given speed, a selected speed, and during climb it will use the N1, so it will go with the engine up to the arrow, and with that power and that speed, selected speed, you will achieve a certain amount of rate of climb. Then we have the VNAV. VNAV connects, links the vertical profile calculated by the FMC with the aircraft. Then we have speed intervention mode. As you can see now, we are in VNAV mode and the window is blank. The IS window is blank in VNAV. But if I wanna change manually, staying in VNAV and changing manually the speed, I can press speed intervention and then I stay in VNAV, but the IS Mach window will be opened. And now I can adjust my speed manually, 0.77, 0.78, or if I press it again, I go again into full VNAV mode and my IS Mach window will be blank again. Heading select, of course, it's pretty much self-explanatory. LNAV, I link the navigation to the route inserted into the FMC. VORLOC is used to capture VOR radials or localizers for approaches. Approach mode, I can use it in two ways. For LPV approaches, or I can use it for localizer and glide slope normal ILS. Alt hold, pretty much self-explanatory, as well as the vertical speed with the vertical speed wheel and window. And then there is the other course. I will keep the altitude intervention button on one side to explain it better during descent. Now we are almost approaching our top of descent. Oh, wow, the sun is rising. Almost approaching top of descent, about 80 miles. So I need to do some preparation for the descent and landing. First of all, we're gonna grab the latest weather for Vegas. So we're going to data link AOC and we go into request, weather request, and we go for Vegas, send, and then we have, what do we have? Message, here we go. 241456 Zulu, okay. 2207 knots, much better than before. 10 miles, few 25, broken 5, broken 10, 12.7, 29.67, okay. And then we have some remarks, but none of them is important, like sea level pressure, and then we got the temperatures, but nothing is important. So we have an altimeter 29.67, so we're going to VNAV, next, forecast, and as the deviation was +4, and altimeter 29.67, execute, and then I am putting some winds in the descent page. Here we go. Let's take 300 and then 18,000 and 9,000. At 300 we have 240.94, 240 at 94 knots. Then we have 240 at 53 knots. And then we have the last one, 240 at 38. Perfect. Execute. Then we have around roughly £1,500 less. So we're gonna be around 135.5. You will see that it's gonna be a 1 knot less. Yes, as expected. So 144, flap 30. I'm gonna go 7 knots wind correction because we might have a little bit of bumps and strong headwind during the final approach. And what else? We need to check the minima that for our approach in Vegas, that is going to be the RNAV GPS Zulu runway 19 right. For an RMP 0.10, let's assume that we are in the most precise side, 25.58. Baro 25.58. I don't need to add anything to this because the RNAV approach, the RMP approaches are considered precision approaches like an ILS. It's not like a VOR where I need to add 50 feet or 70 feet to my minima. Good. And we said that the altimeter setting for our landing was 2960. Let's cross check it. 2967. 2967 is preset. And I cross check also here, 2967, right. And let's have a look at the route right now. Here we go plan mode, zoom in a little bit, legs, and then what we're gonna do is to fly all this arrival going south of the airport. Then from the south side we fly to Bourbon, then turning left to Penn, Kiwi, Mop, and then performing this RMP AR approach. This is called RMP AR. AR stands for authorization required. Why? Because it has a turn on short final. This is the most simplific way of explaining why an RMP approach is AR, because it has a turn on short final. And what does it mean? It means that to be able to perform these, pilots needs to be trained specifically for these kind of approaches. Then the aircraft needs to be certified for it, and the airline as well needs to be certified for RMP AR approaches. And sometimes, let's go here into the airport. I'm just closing down Reno because I don't need it. I'm going to Vegas right now. So plates, let's take the RMP AR Zulu 19 right. RMP AR Zulu 19 right. It says authorization required right here. Authorization required. RMP AR approach. Okay. So this is the procedure, and what I was telling you is if we look down here, you'll see we have a lot of different minimums for RMP 0.0, 0.20, 0.30, and another one with the RMP 0.30 without the missed approach requiring the minimum climb gradient of 300 feet per nautical miles up to 3,000 feet. So these minimums are depending on the type of the certification that the airline itself has. So, for example, we can have a determined airline that can be certified down for the RMP 0.10, which is the one that we are simulating today, 2558. But we can have another airline that is able or capable to be certified only for RMP 0.30. So that means that with the same equipment, with the same aircraft, you could have sometime an airline that is sometimes it is continuously able to land in some place, and sometimes it is not. So it's quite important to see and check the capabilities of the airline every time. Sometimes you might have an airline that is able to land somewhere, and sometimes another carrier cannot land in the same place where somebody else has just landed because of this. Last few things for our approach. Auto brake, we're going to use auto brake 2, idle reverse, that in the simulator will correspond about at 50% N1. So we are really close, top of descent, less than 7 miles. Let's start our, and we hit altitude intervention. I said before that I would have left the altitude intervention button description for later, and now I am explaining a little bit about what altitude intervention does. It has 3 functions basically. The first function is linked to the function that we have just used. So at the top of descent, we want to initiate the descent before the calculated top of descent by the FMC. So we wind down the altitude knob and we press altitude intervention. The aircraft goes into the descent mode. It's the same function as if we went to the descent page and hit the descend now button. There is no descend now button now because we have already armed the descent with the altitude intervention, but the function is just the same. Then another function is during climb. What does it do? During climb, we might have restrictions, altitude restrictions during our climb out. So for example, we are climbing in VNAV on an SID where there are many altitude restrictions, and we want to continue to climb in VNAV to be protected for speeds, but ATC is clearing us to force those altitude restrictions. So whenever we press the altitude intervention button during a climb, we cancel the next restriction. So for example, out of London, Gatwick or Heathrow, there are a lot of restrictions. Maybe the first altitude is 3,000, then you have 4,000, then you have 5,000, then you have 6,000. Is always a step increment of 1,000. So if the ATC says climb unrestricted level 200, then you wind up to level 200, the altitude window, and press maybe 5, 6, 7 times the altitude intervention push button to cancel all the constraints during the climb out. Same applies as well during the descent. The last way you can use it is at cruise altitude, and it is used to change the cruise altitude without actually acting on the FMS, on the FMC. Let's assume that we were cruising as before at flight level 350, then for whatever reason we'd like to climb level 380 or 370, sorry, 370. Then, without going here into the VNAV page and then going into the cruise page, typing in 350 and so on, we could have just wind up to 370, for example, and hit the altitude intervention. Then the aircraft automatically goes into N1 VNAV speed climbing to 370, and 370 goes already into the FMC as a new cruise altitude. So it's a very nice feature to have. All NGs have altitude intervention and speed intervention. On board the Classics, you don't. You have only some of them that have been upgraded to this new MCP panel. Some other have not been updated, so you don't have these two buttons that are quite useful, at least to me. And of course, on the 737 MAX, you have exactly the same MCP. So there is no problem. So this is of course also the newest version of the MCP of the 737. Some NGs, the first one, have the hold. I think it was made by Collins. This is the Honeywell MCP, and the old one with the amber dials was the Collins one. And the Collins was installed in all the Classics until I think maybe 2010. No, maybe, yeah, slightly more. 2000, sorry, slightly less, maybe 2008. All NGs also had the Collins autopilot, and then they changed into the Honeywell. Same things as well for the standby instruments. At the beginning they were all conventional, and then they changed to be a single integrated standby system. We can continue to descend 16,000 right now, according to the vertical profile. 16,000 set. So now the auto throttle is kicking in to keep the speed. And now a little bit of chatting about our approach. We're gonna fly this RMP-AR. How are the RMP-AR approaches flown? Well, I made a separate video about this. I think it's almost a year-old video where I was talking about RMP approaches, taking as an example an RMP approach in Palm Springs. But nothing have changed actually. Basically, depending on the system of the aircraft, of the 737 you are flying, and depending on the certification the company has, you can use two ways of flying an RMP approach or an RMP-AR approach. You have the LNAV VNAV way, or you have the LNAV approach way. What does it mean? It means that for the company I'm flying for, we are only allowed to do RNAV approaches, RMP approaches using LNAV and VNAV. For this, the procedure is when we come to the platform altitude, that in our case for this approach is going to be 6,000 at Penn at 210 knots, we will arm VNAV, LNAV, of course. We will open the speed intervention, and I will show you later on why. Then wind down the altitude knob to the minima, 20 to 58, rounded up to the next, so it's going to be like 2600. And then the aircraft is going to follow the profile vertically and horizontally as it was a descent profile right now. So to be able to do that, the aircraft needs to know certain parameters. And first of all, we don't want the aircraft to be distracted by any VORs in the vicinity. We want the aircraft just to fly on the GPSs on board. To do that, to tell the aircraft to do that, we go into progress and we go on the fourth page. No, sorry. I need to keep it up because it's a long time I'm not doing it. We go onto the index nav status, page number 2. We go to VR update and we turn them off. This is not possible here, but in the real aircraft I would do that. Then the other thing I would do before starting an RMP approach is to go on prog 4 page and then change our vertical deviation RMP to 125, like that. This of course will tighten. Okay, we are passing the transition level 2967 set 1, 2 and 3 times, and we can descend 12000. 12000 set, and I'll just take a break because we forgot, or I forgot, to run the descent and approach checklist. So pressurization, landing altitude is set 2200. Recall check. Auto brake level 2. Landing data VRF 144, minima 2558. Approach briefing completed. Descent checklist completed. And then we go into the approach checklist. Altimeter 2967, set and cross check, and the checklist is completed. Good. Yeah, I was saying here we have now a narrower band for the vertical deviation allowed. This means that when we are performing an RMP approach, we are primarily concerned about the fact that our vertical deviation may become excessive and we can become too low on the profile, and then we can hit the terrain. This is definitely what we do not want to. So usually, normally, the vertical profile, the vertical deviation is set up to be alerting the crew when they are deviating more than 400 feet. But 400 feet in an approach can be too much, can be way too much. So that is why we want a narrower limitation. 125 is perfect. And this is very important, especially when performing some kind of RMP approaches near to minimums. Well, this is not the case today in Vegas. It's nice weather, let's say nice for Vegas. Usually Vegas is sky clear. Today is a little bit cloudy. There is this Christmas storm raging into the west coast, even inland. And now we have a nice overview of Vegas down here with the laser going all the way up into the sky. Yeah, here we go. And here's the airport down here. So what we're gonna do is to go all the way around the airport and then land from the north. Okay, what we can do is to continue descent, I guess 1000 at least. 1000. VNAV path is correct, and then our limit is gonna be 8210 at Bourbon. I'm just reducing the scale a little bit because now we want to see better.
1000 to go.
Okay, 1000. Then now we have 9000 next limitation at Redquin, and then we have 8000 at Bourbon. Then after Bourbon, what we're gonna do is to fly to Penn, descending at 6,000 feet, and then the FMCs already knows that we want to be 210 knots or below at Penn, and it will arrange our descent according to what the procedures requires. So nice. We are really low. Sorry, I had to put seatbelt signs on, a little bit of external lights as well. On a low altitude or a low elevation airport, this would be a perfect altitude. 10,000, it's a good gate to set the seatbelt signs to on. But in Vegas, with an elevation of what is it, like 2,000 feet, we are a little bit late, like 2,000 feet late. 8 degrees, I prevent icing, setting engine start switches to continuous and engine anti-ice on before going into the clouds. We are also expecting the temperatures to drop for 2 reasons: going into the clouds, of course, and slowing down as well. So approaching Redcon, and next will be Bourbon at 8,000. I can already set 8,000 since 9,000 at Redcon are assured. And speed 210, and the aircraft, as you can see, is already decreasing the speed to be at the prescribed speed at the prescribed point. We have quite a lot of tailwind now, so we need to help. Absolutely, we can do this using a little bit of speed brake, helping the aircraft to decelerate, because we have the engine anti-ice on, and it will increase the idle power of the engine, and we have also like 30 knots tailwind, and of course this is also making us a little bit difficult to decelerate. For later on, this is the last chance to check the parking spot. It's going to be Charlie 11 for us, and Charlie 11 is situated on the concourse Charlie, of course. After landing, then we're going to vacate to the left, and then we take it from there. So good. Approaching 6,000, then here we go. Top of descent 8,000, sorry, 8,000. So next step will be 6,000. I can already select 6,000 here, and being sure that I have VNAV path on the FMA. This is the most important thing, because only this VNAV path is telling me 100% sure that the aircraft is actually following the VNAV path of the FMC that is being calculated onto the FMC. So turning now left inbound Penn, most probably this, sorry, speed brake in, sorry, this would have been the vector or the vectoring that we would have get in the real life if we were number 1, of course. In real life as well, this would have resulted in getting a flight data monitoring warning, because we are I'm going into adding select, because the aircraft, I think it's not really able to understand where to go in this kind of way. So I'm just turning a little bit to the right as well to be able to have a little bit more miles to turn, like going on a downwind, for example, at 6,000. And then what I'm doing is to prepare direct to Penn, like that, to prepare it. I need to be 6,000 at Penn, and then it's going to be 5,300 as Kiwi, which is the next point. I also want to decelerate, because this is a pretty tight turn, so I'm gonna just do start to extend flaps. So flaps 1, as you can see, staying in VNAV, the speed is going to decrease automatically. So pen again on top. Here we go. Execute LNAV. Perfect. Very nice. Then we want to descend to 5,300, which is the next step at Kiwi.
1,000 to go.
Perfect. 180 knots sounds perfect for these kind of turns. As you can see, the turn predictor is staying inside of the magenta line. So it is good. Turning a little bit tighter now. And I can turn the engine NTIs off for sure. I can leave the engine start switches to continuous because we will need it to continuous for landing. So nice. Pen is gonna be on top. We have VNAV path and we have FMC speed. And the vertical profile is coming down. 5,300 is the beginning of our procedure, the platform altitude. So now the aircraft is going to descend. And then, before reaching Kiwi, I will wind down my altitude to the minima, 2,600. Okay, now we are on profile.
1,000 to go.
And the aircraft starts to descend. The altitude at Kiwi is assured, so I already go down here to 2,600, like that. LNAV, VNAV we have. I open the speed intervention window and go flap 5. We have VNAV speed and FMC speed, so it's good. It's the right way we want to have the aircraft configured. And waiting for the aircraft to catch the vertical profile. Now we start to decelerate a little bit more, even though we have no other speed restriction along the arrival, the approach. As you can see now it's descending, FMC speed, LNAV, VNAV path. That's the correct way we want it. Down to the minima, everything is set up. In the meantime, we continue to configure. And we receive the signal from the cabin crew that the aircraft cabin is ready. And we say, cabin crew, be ready for landing. Nice view of Vegas. And the airport there. Okay, radio altimeter alive, gear down. Flap 15. And now the aircraft starts to turn automatically according to the arc prescribed. Sorry, I have to restart my audio engine. I don't know why, sometimes it goes away. Flaps 25. Flap 30. We want the final speed and landing checklist. Cabin call given, engine start switches continuous. Speed brake are armed, yes. And landing gear down, flaps are 30-30 green lights. I don't know why the speed brakes are not arming. Yeah, now they are arming. Good. Checklist completed. 1000 feet stable, and we are clear to land. Turning left. 194. 194, and I forgot this. Sorry for that. 194 should be. Let's put it only on my side. Runway is in sight. 19 right. Almost approaching the minima. We can turn up to 7000 here for the missed approach.
500.
We are hitting the minima. Runway is in sight. Disengaging autopilot and auto throttle. Good.
Minimums.
And now it's visual. Clear land. Runway 19 right. Wind is straight from the runway.
100. 50. 30. 10.
A little bit of ballooning effect. Sorry for that. Quite long landing anyway. Yep. Speed brake up. Two reversers at 52%. Plenty of runway anyway.
80 knots.
Checked. Manual braking, auto brake disarm, 60 knots, reverse out, and vacating to the left. At Yankee. Welcome to Vegas. 56 minutes flight time. Good. After landing flow, let's go really slow because it's quite easy to mix up things in this kind of condition where we are taxiing and performing the flow single pilots. Let's assume that we have been cleared to cross. Good. And then we are taxiing to stand Charlie 11 out of active runway, so we can do like that. There is no after landing checklist on the 737. And here we go. Now we are taxiing Bravo, then taking Bravo 5 northbound to join the apron to stand Charlie 11. Much better weather in Vegas than in Reno. Indeed. In the meantime, start APU. Starting APU. The procedure says that the spring-loaded APU switch must be held in position start for at least 3 seconds for the APU to start its power-up sequence. Anyway, it's starting. That's good. So we are approaching now Golf. We pass Golf. Then we have Bravo 7, Bravo 6, and then we have Bravo 5. This is Golf. This is Bravo 7. This is Bravo 6. And down there we have Bravo 5. That is going to be the one that we will be taking. APU is available and on bus starting 1 minute warm-up time. Here we go. Bravo 5. This is the one. Slowing down and turning left. Then we are turning right, then left again to take the Bravo 1-1 position. Sorry, the Charlie 1-1 position. Charlie 1-1. Here we go. Start guidance. We should have the follow me car around here, if I'm not wrong. Where is the follow me car? Let's go on the outside and check. Oh, was on the other side. Why? Because Charlie 1-1 is this one. My mistake. So we need to turn. My mistake. Charlie 1-1 is this one in the middle. Here we go. I go behind the follow me car. Perfect. Taxi light off not to blind him or her. Or she. And here we go into Charlie 1-1. APU is running, all taxi lights off. APU, we have already 2 minutes power up, so it's more than enough. Then as usual I'm going outside for a manual parking, even though we have the marshaller. I do it manually. I prefer a better alignment with the yellow line. Good, it looks like it's perfect. Parking brake is set, and then we have APU on bus, engine number 2, cut off, seatbelt signs off, engine number 1 cut off. Then the flow on the overhead goes like this. Then we go here, up here, then here, then this is done. Transponder code back to 2000 and code is reset. I'm just cross-checking to have done everything, and I guess so. Let's connect the jet bridge. We want the Charlie 1-1. Open some doors. Call for some services. GPU is now connected, so we can take the GPU and power off the APU. That's all good. And run the shutdown checklist. So fuel pumps are all off, probe beats all are auto, automatic panel is set, flaps are up, no lights, parking brake is set, engine start levers cut off, weather radar is off, technical log is completed, EFB is completed, and the shutdown checklist is completed. as well. Now the jet bridge is connecting. Here we go, almost there. And welcome to Vegas once more. I hope you enjoyed the flight and enjoyed the curiosity on the Autoflight system of the Boeing 737. I will leave you with some cinematics of the approach and landing in Vegas, despite it was not the best one. But thank you very much for supporting this channel. Hit the subscribe button if you like this, and like the video. Have a wonderful Christmas time. Season greetings to everybody. Thank you for your support. I'm FlyLore737. Stay healthy, stay safe, take care of each other, and see ya.